Hey everyone, this is part 2 of our Docker series, and in today's video we will see about Docker file, images, container, registries, difference among these four, and then how do we actually run our containers, download them, and then common commands and flags that we should know, especially as a DevOps guy, to actually manage those containers. Okay, so first let's see the difference between Docker file, image, and containers. RS. So, Docker file is basically a file that has all the instructions on how to build this image. Image is basically a snapshot. Okay, you can say snapshot or template, and when you execute this template, you get containers. Okay, we will see this with an example. Think of it like this. Let's say we want to make biryani. Okay, just stick with me. We want to make biryani. So we would have recipe guide. Recipe guide. In this recipe guide, you have instructions, set of instruction like okay, you have to get, let's say, these spices. Then you have to get one chicken. You have to get some, let's say, 250 grams of rice or something. You have all these instructions, right? Now when you actually follow this instruction, you get what? You get the actual dish. Okay, I am bad at drawing, so okay, this is like what, chicken leg? Yeah. So this is our biryani. This is not in use as of now. Okay, this is like the prepared thing. This is the final thing, but is it is still just sitting idle. Nobody is having it. Okay, now when you actually serve this, so you are serving this, people are now eating it, and everyone is happy munching it. I would be happy munching it. uh, so if we see this example in multiple phases, so here when you have this recipe guide, this guide is actually in containers. We have docker file. In docker file, you will mention all the steps, all the files, your source code, some extra dependencies, application, whatever you need to build the final application. You will simply define here. Okay, you will define something like, I will show a docker file later in the upcoming videos. So it will have something like, uh, from add, then work dir, let's say run cmd. There will be multiple parameters like these which you can use to build your application. Now when you follow this docker file, you will get your application. This is not a running instance of your application. Okay, like your application is not being used, it is not being served, it is just simply sitting idle there. Nobody is using it, and it is basically a snapshot, a blueprint, a template of your running application. Think of it like this. You install something, you install an application. Okay, it is xyz.exe. So this is not the running instance of that application. Okay, this is simply a template. When you execute this exe file, it will simply do some extra task like unzip some files, make some directories, copy some file here and there, and then you will get the actual application exe. Okay, so it's something like that. This is your application. This phase you, or you did got your application, but you are not actually using it. Okay, this is just a static sitting idle template of your application. And when you run this application, okay, when you serve this application, you serve this image, you get your container. We will see a bit about this very soon. So this is like the difference between your images, containers, and Docker file. Next is registry. So now, first of all, registry is basically a place where you can host your images. Okay, you are not hosting your Docker file, you are hosting the static template of your application that you built from Docker file. Okay, so registries are, there are two types of registry. Think of it like, GitHub but for images. Okay, so there's public and private images. So in public registries, it's completely open and public, right? Anyone can see the images, anyone can download it, anyone can use it. Think of it like a public GitHub repository, right? Anyone can see, anyone can download, anyone can fork it, clone it. Same with that. In private repositories, you need authentication and permission, right? Permission. You need to have some permission to access those images. So for authentication, let's say you want to download the image, you want to see what are all the images published by publisher. You will need to have some credentials for that, and then you should have permission. Now, Docker Hub is a very popular registry. This is like a registry officially from Docker themselves. In this, you get public and private both. Where if you are a member, free tier, you will get one private repository, and then you can have like infinite public repositories, only one private images. Then there are some cloud companies, for example AWS. AWS has ECR, Elastic Container Registry. Now this is the Docker Hub, and here you can see all the images. And if you want to look for any specific image, let's say Ubuntu, you will search that. Go for the official images, because they are again from official people, they are well secured. You have these three tiers. Okay, official, verified publisher, and sponsored OSS. Apart from these three, if you are installing someone else Docker image, then just be cautious. Make sure what you are installing is safe, and there are no hidden malware or anything. Okay, so let's say I want to download this Ubuntu. I will just go there, and then here this command, it will simply download this Ubuntu. Now this is the name of the container. Docker comes pre-set up with Docker Hub as your official registry. So by default, you don't need to define any setup for using Docker Hub. Okay, it will be by default. If you want to use some other container registries, you would have to configure that. But here we are using Docker Hub. Now Docker pull Ubuntu. Ubuntu is the name of the container, and then this after semicolon, it is actually the version. So you can see there are many versions. Let's say I want to download this 25.04. I will choose that, and then it simply gives you the version tag. Now if you do not define this part, it will simply pulls the latest image that this repository have. So let's go to our terminal. Okay, so to download the image, what we can do is docker pull Ubuntu. Now if I do not define anything, I will simply use the latest tag. Okay, so whatever there is latest, it will simply download. Now this image is already there for me in my system. Let's install something else like Python. Okay, since I have not defined any version, it will simply download the latest version. It will not execute the container image, it will simply download the file and save on our system. That's all. So now the image is downloaded. If you want to see all the images that you have, you can run docker images. It will give you all the images that you have downloaded. Now here I have Python latest, Nginx latest, Ubuntu I have two versions. the latest and 25, and this is a hello world image from Docker. Here we have the size, how much these images take space, and then their image ID and when they were created, all that. Okay, now to run a Docker image, you simply say docker run and then the name of the image, nginx. Okay, now if I run this, as you can see, I am inside this. I'm not actually like inside, but I am connected to the PID one of this image. So I have lost access of my shell. Okay. So if I press Control C to exit now, it will actually, kill this container. So this container is stopped now. So to not, to have your shell also and run this container in background, we give this flag dash D. It means detached. Okay, so what this will do is it will simply run the container. It will give you this is called the container ID. Now you can use the starting 4 to 5 digits to run other commands on the container. You do not have to give this whole thing, or you can give the name of the container. So now this dash d basically runs your container in detach. If you get this, you can say like, okay, your container is actually running. Now, how do you see if your container is running? So for that, you have Docker PS. Okay, this will give you the status of the running containers. So as of now, we ran nginx, and you can see like it's A5BA52, A5BA52. Okay, same container. Then this is the random name. When we do not define any name, containers get a random name. So this is relaxed Bartik. This is the port that this container is exposing. So it's a nginx web server container. So it is exposing 80. This is the status. This was like when it's created, and this is the command. By default, this container is running. We can overwrite it, but as of now we do not have to do that. Okay, and the image that we are using. Now, if you want to see, Docker PS has two very major flags. That is dash Q. It will simply give you the ID. Now, this is very useful when you are scripting something. There is a very nice command substitution for this. So basically, PSQ will give you the container ID of the current running containers. Now, if you do PSA, this will give you the list of all of the containers. It will include the stopped containers and the running containers. Okay, so it will have data about all of the containers. So if I press A, as you can see, I have ran a lot of containers for the testing purpose. So these are all these container IDs, and the images they are using those random names. So these exited means they have been stopped. So these all containers are in stopped state, but only one is running. So docker ps gives you the current running container. Docker ps gives dash a gives you the all of these containers, be it stopped or running, and docker ps dash q gives you the container id of the current running container. And if you combine it with aq, it will give you the container id of all the containers that are running or in a stop state. Okay, so this is all about docker ps command. Now let's get back to running our containers. So now our container can run in detach mode, but let's say I want to get into this container. Okay, so I want to run nginx, but also get inside this container, have the shell access, and let's say do some additional commands. For that, we can run dash it. It means interactive terminal. Basically, it will assign you a tty for running your commands. Okay, so this is a nginx container. Now here's the thing, as I showed this thing, docker ps You see this command? So every container has their own default command, right? Now for nginx docker run dash it nginx, nginx runs nginx server. Okay, so when I run this without any extra option, it will again attach me, connect my shell to the running process of this container. So if I press enter, as you can see, I am now again into this interface where my shell, I do not have access to my shell. My shell is connected to this nginx container, and if I press Ctrl C, I will simply stop the container. So to not do that, what we do is simply, uh, after your image name, just give the command. So here I am giving bin bash. Now it can change. Okay, it can be bin.sh, zsh, fish, whatever shell that is in the container. So in nginx we have bash, so no problem. What this will do is it will create another additional process and it will attach us to that process. So in this container there would be two running session. One would be for the nginx default application server thing, and the second would be this bash session. Okay, so now if I run this, as you can see, my uh, this has changed to root at the rate this. So this is the user, and root is the user, and this is the host name. The host name is also random. We will later see how to define your own host name. So yeah, now I am in container. If I, let's say, do ls, and if I do ls here, you can see the contents are different. Now if I want to exit this container, I will simply just say exit. Okay, if I go again, okay, there is no ps. If you would have run ps here, you would see all the processes. So yeah, that is how you get into the container when you are running it, like for the first time. Okay, there is another command that you can do for pre-running containers. That is, first let's say docker ps. I have this container running, right? I will copy the container id, or you can copy the name also, anything. Now this container is already running and I want to have the shell access of this container. So I can say docker exec dash it. We want an interactive terminal, right? And then the container id, and then the command. It will be bin slash bash. And now I am into this specific container, okay, which was already running before. I am now logged in into this container. Okay. Okay, now let's see how we can give our container a custom name instead of something randomized. So we can, let's say, docker run. So we will use the dash name flag. So let's say I want to name this container as test1, and then the name of the image I will use nginx, and I will do it in detach mode. Okay, so dash d. Now if I run docker ps, you can see this be4014. Okay, and you can see the name is test1. So now if I want to like get into it, I will simply just say test dash 1. Okay, and I'm now into this container. Okay, so we have two containers running. Okay, these are on 80 ports. Now these containers are running in their own separate environment. Okay, let's say this box, this is your host. Okay, inside of this will be running docker containers. Okay, they have no direct access to your host. So let's say your host has its own set of ports, right? This container has its own port, its own ip, its own port. Okay, it is running into its own environment. Okay, think of it like, when you are running a virtual machine on your host, those two are very separate environment, right? So when we are running nginx, it is actually inside this bubble. Okay, this is our host, this is nginx, it is running in its own bubble. Now if we want to access this nginx web server, we would have to create a link between this bubble and the bubble of our main system. Okay, we will have to simply connect our container to our host. For that, there are multiple ways which is Docker networking. We will cover this in detail in the next video. But for now, there is this thing called port mapping, where we will host port. We will map or basically bind or connect some port number from our laptop or our machine to the port of our container. So let's say our nginx is running on 80, right? So what I can do is I will assign let's say 8080 of my machine to 80 of this container. So when I visit on my local host 8080, the traffic will be forwarded to this 80 port, and then whatever content is being uh, shown on this port 80, it will be shown on our system. Okay, so basically the data is getting transferred from this port to the port of container. There is a link between container and host system now. So to do this practically, uh, we are running, let's say, test 2 detach mode nginx. Okay, now we want to actually access this nginx, right? So what we can do is dash p gives you the option for port mapping. So the first port will be your host port, your laptop, your main machine. Okay, so I would use 8080, it is free on my system, and then the port number that this container is running. So nginx is exposing on 80, right? These two are running, but they are not exposed to our 8080. Okay, so same containers, same ports, they can run multiple times. Okay, there can be multiple instance of a container running same port, but when you do the port binding, you will have to make sure your host port is free. Okay, so now if I run this, I got a new container. If I run docker ps, now here you can see this 8080, uh, basically these, you can see like, okay, these two are simple. Here there are a lot of things. So what this mean is this 0.0.0.0, it means like all of my interface, all of the networks. So in my network, this 8080 port is now mapped to this 80 of the container, and then this is like the IPv6 equivalent, this is IPv4. So if I would go to this, this 00 would be the IP of my own system, or you can say the local host, and I would go to 8080, I would see the nginx landing page. Okay, so if I, let's say, see the IP of my container, not my system, it is 192.168.1.51. Now first let's go to localhost colon 8080. You can see we got the nginx landing page. Okay, also if I go to 192.168.1.51, I can still see the landing page. Okay, anyone in my network can now access this page. Okay, so this is basically what our 8080 port of our system is now connected to the port 80 of the container. Okay, if I, let's say, try to run this same thing, let's say another container, this will be again a new container, right? But since the port 8080 is already allocated, it will fail. As you can see, fail to set up container networking, port is already allocated. So I would have to change the port number 8080. Oh, the name, yeah, let's say test for 8081. As you can see, now it is running. So if I again go to localhost colon 8081, I can see the landing page. Okay, this we will cover more in the docker networking to, like, how we can expose our application in multiple ways. But yeah, this is like the basic you should know. Now here's one more cool thing is, if you do not want to do this port mapping, you can simply give a capital P. So in the capital P, Docker will randomly assign a to your container. Okay, if I run this docker ps, and this is test 5, right? You see this test 5, 32768. So now this random port has been associated to the port 80 of container. So if I go to that random port localhost, you can see the nginx is running. We can actually, like, do one more thing. Let's say docker exec it test dash 5. So yeah, if we go to user share nginx html, like in container, we use this. There's the where www also in the main application. So now if I go here, there's this index.html. Let's say if cat is there, okay, it is there. Cat index.html, you can see this. If I edit this file index dot, okay, it's not there. Let's do this. Echo hello from Luffy into this index.html, and we exit. If I reload this, hello from Luffy. Okay, so you can change the content of the container, right? So now the next we do is how do we assign environment variables? Okay, let's say our application needs some predefined environment variables in the container. Then we can do this docker run. Let's say I want to run Ubuntu, okay, but first we will also get into it also, so we can check if the environment variables are assigned. Now dash e flag is used to assign environment variables. So like dash e hello equal to world, then dash e. If we want to give more than one environment variables, we would have to just use dash e flag again and again, and it will be in a key value pair. So here is your key, then equal to, and then the value of it. Here we can say uh, what do we say, user is equal to Luffy dash e, docker is equal to cool, okay, Ubuntu. Now as you can see, I am inside this container, right? If I do env, we can see all the environment variables assigned to this container, and here you can see hello equal to world, then user equal to Luffy, docker equal to cool. All these environment variables are now defined in this, okay. Like docker run dash e. So instead of this, let's say if you have any env file, you can use env dash file, and then the file, okay, let's say test env file. So there is some env file you have, so you can use this flag to pass that env file, okay. Now the next is how can we define host name. Okay, we want some custom host name, we do not want a random host name. So let's say docker run, this name of the container is different thing and the host name is different, okay. So I will actually use this rm flag. I will tell you what it is, and I don't want to detach mode. I will simply exec into it. I will run Ubuntu. Now to define a host name, you will run host name and then the host name you want. So let's say we want it as server dash prod. We want to define this as host name. I press enter. Docker run helpful. Okay, dash, yeah, this it. Yeah. Now as you can see, server dash procs. So this is like the host name, okay. User is root and the host name of our container is this. You can simply cat out /etc /host name. You can see it's server procs. So this is how you define a custom host name. Okay, so now we have Okay, one, two, three, four, five containers running. Okay, now we want to stop them. So for that, the command is docker stop and then the name or container ID of the container. So let's say relax batik docker stop, and this has been stopped. If you see this, that is gone, right? So let's say I want to stop all of this. So remember this docker ps dash q, it is giving you all these container IDs of the running container, right? We can do this. We can do substitute the command docker stop and then like this docker ps dash q. So what going on here is actually this command is different, this is different. So basically the output of docker ps dash q, this will be a input for this. Okay, it's something like that. Okay, so if I run this, it has stopped all this container and I run docker ps, nothing is running. But these containers are in actually stop state. Okay, so if you run dash a, as you can see, they are exited, but they are still there on your system. Okay, later we will see how we can remove them. So now I want to show you this nice dash dash rm flag. Okay, dash rm means remove the container as soon as this container is stopped. I am running this, okay, container, and let's just name it dash dash name uh, rm rm cont. Okay, I press enter. The container is running. Okay, so if I open another session docker ps, as you can see our rm cont is running. Okay, now if I exit this, okay, docker ps, no container is running, but when we exit the container simply is stopped. Okay, as of now, so this container should be shown when we run the dash a flag, right? So when I run this, as you can see, there is our rm count is not here. Why? This rm flag will basically remove the container as soon as it is stopped. So let's try this with nginx dash dash name rm nginx, and I run nginx. Okay, oh wait, detached mode. So we have one container running, and then second container I will run without this, and the name would be no rm. Okay, so now docker ps, these two containers are running. Now if I stop these two containers, okay, docker stop this rm nginx, okay, this container has been stopped. If I stop no rm nginx, these two containers have been stopped, right? Nice. Now if I run docker ps, both are stopped. If I run docker ps dash a, and if you see, no rm nginx is in the stop state, but you won't get to see rm nginx. Okay, why? Because when we ran this rm nginx, we ran it with dash rm flag. So as soon as this container is stopped, as soon as we stop it, this container will be removed. But since this container had not rm flag, so it is still there in the stop stage. So that's the whole difference between this. Now there's also these commands, okay, like uh, dash dash network twork dash dash volume. So in these commands what we are doing is defining some custom network and some custom volumes, but I will show them in the later videos when we will cover these network and volume topics in detail. Okay, let's say I want to run a container as a different user. So normally when we are running these Ubuntu, let's say RM, and we cannot pair dash it and dash d together. Okay, you will get nothing actually. So you either run dash it or either do dash d. Okay, now when I run this, as you can see, I am running this container now as root user, okay, by default. But what if I want to run this as different user? Now for that you have to make sure that user is present in this image. How you can make sure that? You can either modify this container and make sure that user exists, or if it is your own container, you would have that step set up in your Docker file, okay. But yeah, Ubuntu also has this user, Ubuntu, bunt Ubuntu by default. So now when I run this, ins- as you can see, instead of a root user I am assigned Ubuntu user. So this is very useful, and it is one of like the security thing. When you are creating your containers, you have to make sure there are some non-privileged users that do not have the root access entirely. And when those containers are running in the production through Kubernetes or anything, they run as those non-privileged user, okay. So they won't run as root, but they would run something like Ubuntu or any other user which have less permission. So it will make sure that if the container has some exploits, vulnerabilities, and it get hacked, you will not get a privilege escalation case, okay. So it is very important from the security point, okay. Yeah, so these are like the basic things you should know when you are running the containers. So like if we define all of that, okay. And by the way, all this will be posted on my website. I will give you the link in the description or comment somewhere, I guess in comments. So that dash d, it will okay, nvim random. So you have dash d for detached mode, you have dash it for interactive terminal, you have dash dash name to name your containers, then you have dash small p for host slash container port mapping, you have dash capital P for random port mapping, you have dash dash env dash file and dash e key value. You have this for your envs, and then you have dash rm to simply remove your containers when it is stopped. You have dash dash host name also, and then the name of container to give you host name. You have dash dash user to run your container as a different user. I wanna show you one more, that is restart policy, okay. Okay, so now to use the restart policy, let's take two case. If we are running two containers, okay, docker run dash it, or else let's see if we have anything running. Nothing, okay. Docker run dash it dash dash name random one, and we will be running nginx, okay. And let's just run it as detached mode, and we will be using dash p 8085 colon 80 of the container and run. Now if I go to 8085 of my system, as you can see I have nginx. If I get inside this container uh, random one slash bin slash bash, and if I kill the pid one, okay. So if you here see docker ps, the container is running. If I kill this, as you can see I got to kicked out of the session. I docker ps, nothing is running, and my web server is now down. I want to prevent that, okay. So what I can do is I can run this same thing with a policy that is dash dash restart restart. If I run now, let's say always, and now if I run this container random 2, I have now another container. It is running on 8085, but if I, let's say, docker exec it, so I will now enter into this docker ps, and simply let's just watch this docker ps. Okay, uh, so if I kill this docker container, I simply press enter, and if I go to this, as you can see, it's still running, and as you can see, docker ps, it still is running. Uh, if I just exit out that command, docker ps, this command is still running. What happened is when I ran this command, it killed the container, okay? But since it had a restart policy, it simply restarted the container again. I have this policy on all of my containers in my home lab. I will show you that someday. So these are all the command common flags that you should know. Now the other thing is docker stop, start, restart, pause, unpause, and then container id. What these will do is very simple, docker stop container id, it will simply stop that container. Then if you want to start that, you will use the start flag. If you want to restart a container, you would do this. If you want to pause a container, basically, you simply just suspend the container. So it is loaded in memory, but it is not doing anything, in that state. You can do pause, and now to unpause that container, you can run unpause. So yeah, it's very simple. The next would be to executing commands. Okay, so as I showed you, docker exec, this will simply uh, run, give us a session, right? And we can simply define what commands we want to run here. Now if I exit this, here after the image you simply define the commands that you want to run. So if I press ls, it will simply run the ls. Okay, now what if I want to run this container as some different user? Okay, so there can be different user, let's say, uh, as of now these containers are running on root, so it doesn't matter. But if I, let's say, want to run this container as user nginx, sorry, I want to run this command, ls command, as user nginx, I would define this like this. Okay, and let's say I want to change the directory. Right now it is running ls in the slash. Okay, but let's say I want to do ls in at etc, so I can define that working directory here. Okay, so slash etc and random.to ls. If I run this, I did not got inside the container, but what is, we simply ran the ls command outside of container, and that too as user nginx, and we defined the working directory, so the directory where these commands will execute. So whatever we type here, it will be like this. So okay, so as you can see, if I run this command, the permission is denied. But if I change the user to root, and now if you run, let's say, ls, you would see some file named abc here. Okay, so this docker exec simply means to run commands. Okay, now we can define the user, we can define the working directory, and then here we define the command that we want to run. We have to make sure, whatever command we are running, it can be run in the container, like the binary files are present there. Okay, so this was our exec. Now how do we see the logs of container? Okay, let's say some container is crashing. How we will see that? We have this container running, uh, random 2. Okay, so I can do docker logs and then the name of the container. It simply printed out all of the containers, like, okay, it started, it got some request here, then we killed the container, we exited out of it, it again got started, we accessed the containers. We can also, let's see, docker ps. So if we want to see the logs, like real time docker logs, we can use dash f flag. It is just like the linux command dash f. So this will simply follow the logs. So if I press this, now I can see these logs in real time. Okay, so if I go here and we simply refresh, as you can see the timestamps are changing. Just focus at this. Okay, 53, and now it's simply refreshing and changing the time. So basically this is you we are getting the real time logs of it. Okay, and let's say I run another container and docker stop random dash 2, I guess. So see, we got the container, like okay, the container got stopped, but I guess it should be running docker ps. Okay, the restart policy was not on this. Okay, okay. So yeah, this was your uh, getting the logs and then following. So the syntax is docker logs and then container name slash id, and if you want to follow the logs in real time, you can use dash f flag. The next is inspecting a container. So if I docker p let's just run another container and okay, random 3. Now this container is running. Now if I want to know more about this container, I can run docker inspect and the name of container random 3. This will give us like the whole details about this container. Okay, so like this is the default command, this entry point command. Entry point is we will see this in docker file. Okay, these are basically the instruction sets. Okay, so when we run the nginx container, this command simply starts. Okay, nginx dash g daemon of it will simply start the nginx server. Okay, now you can see like the status is running. This is the hash of the image. This is the name of container, how many times it restarted, and there are a lot of informations, something like the IP address of the container, the gateway it is following. So you get all of the information about it. Okay, it comes handy when we are debugging the containers. Okay, there's also this dash dash format option. So let's say we do not want to see direct all of this. Okay, we simply want to get a specific option. So like let's say I want to get the IP address of this container. Okay, so we would have to like get this main attribute. Okay, like from here we are starting this class. uh, so the format is basically put all of this in your brackets. uh, do this, and then we define the values. So the value was something this network settings. Here you can see network settings. Okay, and then we want IP address, right? Then this value network settings dot IP address. So now if I run this, I will simply get this. Okay, it's kind of like grabbing, but different from grabbing. Okay, so whatever you want, you can do like this. One more useful is getting the image that it is running. So you can run image, and here it would be config. So when I run this, I get the image that this container is running. So this was about inspecting the container. Now let's say I am going to this directory. Wait, cd test ls rms rftmp. I create this file. Okay, let's say touch hello world dot py. I have this code, I have this file. I want to copy this into a container. So as of now, I have this container running, right? Now, what I want to do is I want to copy this file from my host to this container. How we can do this? So the command is simply docker cp, and then you simply define the source and with quotation the destination. Okay, so docker cp The source is this file. Okay, so this file is simply in this directory, so I will just type the name of the file, cp hello world, and then we want to copy this into container, right? So it will go with like this, the name of container. What's the name of container? It's no, it's I guess it was, yeah, random dash 3, and then the path inside the container. So let's say in the slash tmp. Okay, successfully copied this file to the slash tmp directory of the container. So we can simply check docker exec uh, ls slash tmp. I mean, we can simply just set here the working directory slash tmp exec the random 3, right? Yeah. So here you can see this hello world.py is inside this container. So if I want to, let's say, copy something from container to my host, okay, like the reverse case. So let's say I have this hello file. I am simply removing this file. I do not have it here. Okay. Now, if I want to copy something from container to my host, I will simply just type the name of container random 3, and we had the file in slash tmp slash what was the name of file? Hello something it was. Okay, hello something. This wildcard, it basically will copy everything that starts with hello, and it doesn't care what's after the hello. It will simply copy anything that is starting with hello. Okay, now we want to copy it here, so I will simply place a dot. If I wanted in some other directory like slash dot pictures, then I would mm, write the path like this. If I remove this hello from here, so this will simply copy this whole temp directory in the pictures. Okay, so it works like this. So I will do this, and I want it here only. rndo random. No matches found for this. Random 3. I guess it is something with the wildcard substitution. Hello world dot py. Okay, yeah. It was, I guess, this wildcard is not getting supported here. So we will have to give the full name. Now, if I do ls, as you can see, this hello world py is now back in my host. So this is how you copy something from or host to container, or vice versa. Okay, docker cp, then you simply define the source, and you simply define the destination. If it is container, then container goes like this: container name, and then a colon, and then the path inside container, and then the path of host. Okay, it goes something like this. So this is how you copy. Let's say I want to rename a container, like, okay, docker ps. I had this randomly named container, and now I know, oh no, this is an important container. I should name this container properly. We can run docker rename, and then the older name of container, which is random dash 3, and the new name of container we want to, let's say, prod server rename. And now if I run docker ps, as you can see, same containers, it just the name is changed. You see, same container id. So now that we have seen like all these important things, how about freeing some space? So docker images, we have these images, these are taking some space, right? There's also this command docker is, I forgot the command. I would have it on my website somewhere. All about docker system df. Yeah, Docker system df, it will give you like uh, how much your storage is being used. So the images that I downloaded, there are 5 images. Three of them are actively used, so like some container are using these images, so three images are being used, and the size is 1.36 GB, and we can reclaim this much, so like we can free this much. And why only this much? Because these containers are active, so the active containers, uh, the image these active containers are using, we cannot normally remove them, we would have to forcefully remove them, okay? And then there are 46 containers, one of them is active, and this is the size of container, okay? So now we want to free up some space. So basically this docker rm, you want to remove some containers, you can type docker rm and then the name of container random 3. Okay, there's no container like this. Random 2 removed, random 1 removed. Do we have something more? Okay, there's, so basically docker rm, then container name or container id. Okay, then okay, so we have these many images. So if we want to remove any image, docker images rm, and then we want to remove hello world. It's okay, it is using some container. Okay, some container is has this image, so that is why it is giving us, error from the daemon. So we can simply force it with dash f, and then it simply deleted. Okay, of course in production you are not gonna use dash f blindly. Okay, now if we want to, let's say, remove ubuntu, but I only want to remove the 25.04, so I can simply do like this, and then this will remove the image. So if I run docker images, as you can see, now we have only 3 images. Now if I want to, let's say, remove all of the images that I have on my system, so we can simply do docker image rm, and then remember the thing we did previously. Here we can define again, we would have to first, okay, as you can see, dash q, we will get the image id. Okay, cause to run them in that, now we can simply run docker uh, image rm, and then dollar bracket docker images dash q, this will give us the image id. And now this might fail cause we have not used the dash f tag. So let's see. As you can see, it is unable to delete some of them, and we would have to force. So if I just do this, sorry, rm dash f, and now images, this cannot be forced. Docker. So now, as of now, we have only nginx running, and docker ps. I would have to, stop this. Uh, so docker stop prod dash server, we have stopped this container, and now if we do this, all of the images are gone. Now there is no running container, but we have a lot of containers. Okay, we have a lot of containers which are in stopped state. So if we want to remove all of these, we can simply run again docker rm, and then percent this docker ps dash aq, and press enter. Now if we run docker ps dash a, we can see we have nothing. Okay, we have nothing, it's all clear. So if I run docker system df, as you can see, everything is now in 0 bytes. Okay, so this was that I wanted to show you. I actually have a file as of now. Let's say it's somewhere this, yeah. So I have this file. It has almost all the commands and flags. I will simply post it on my website. So these are like, you have to know to manage your containers and the whole life cycle of it, and then additional flags that you can use. There are some additional flags that I have not shown, I guess. Like the CPU and memory. We I don't need it here. We can define it in our Kubernetes. It is more useful in Kubernetes. I will when we do the Kubernetes. But yeah, you can see there are all of them. In the brackets, you can see like these are the option that we can use. So yeah, I will post it on my website. It's blog.homeland.click, and here there will be a new post. I will simply put the link in the comment section. So yeah, I guess that is all. I hope you guys understand this and make just learn all these flags. Okay, they are very important. They will be asked in interviews, and your daily Docker life cycle. They will be very used in that. Okay, so yeah, that is all. See you guys in the next video.